Hello class, this is our review for the first trig test. Much anticipated video. Let's jump right into it. Convert each degree measure into radians, each radian measure into degrees. To do this, we need to multiply by a conversion factor that we know to be true. And we're going to set up our conversion factor so that we get the unit we want on top. So this is clearly in radians. We know that because it doesn't have the little circle and because most radian measurements have a degree symbol or a pi in them. So this is in radians. I want it in degrees, so I'm going to put degrees on top. I'm going to multiply by a conversion ratio. The only thing that needs to be true about this conversion ratio is that the angle measure on top, given in degrees, needs to be equal to the angle measure on the bottom, given in radians. Now, I just say always pick 180 degrees equals pi. It's the easiest one to work with. But technically, as long as this is true, it will work to convert your measurement. You could do a 360 degrees equal over 2 pi. It'll still work. All right, the pi's cancel out. I've got 11 times 180 degrees divided by 6. 11 times 180, that's 1,980 divided by 6 is 330 degrees. Let's go the other direction. I'm given a measurement in degrees. You can see the little circle there. So I need to multiply something with degrees on the bottom to cancel it out. We'll do 180 degrees on the bottom. And what is 180 degrees equal to in radians? Pi. So now I've got negative 240 pi over 180. The degrees cancel out. We don't have to write the symbol anymore. And now we're just going to simplify the numerical part of that. And there's a way to do this in our calculators. I'll show that to you now. If you want, you just have to do the 240 divided by 180. Leave the pi out of it, just the numbers. Then hit math, enter, enter, and it converts it to a fraction. So we got 4 over 3. Now we add the pi back in. And that negative symbol, make it negative 4 pi over 3. So, a little trick for you right there. If you ever have your graphing calculator and need to simplify fractions. All right. Radians, you don't actually have to write rad, but sometimes it's nice. Radians is that unitless measurement, which is kind of strange. Find the measure of each angle. What's given in green here is our reference angle. 25 degrees. Red is what we want. I'm going to ignore positive, negative. I'm just going to trace the spiral and count in terms of multiples of 180 as I go. Since my reference angle is given in degrees, I'm counting in degrees. So here I am at the start of the spiral. I go half around. That's 180. 360. To here is 540. Here's 720. We'll just write, 720. I'm not going to go a full 180 more. I'm going to stop 25 short. So 180 minus 25 equals 155. So 155 for just that piece there, plus 720 for how much we've already rotated. Add them together. And we get 875 degrees. At this point, we think, did I rotate positive or negative? Counterclockwise is positive. Clockwise is negative. This is clearly clockwise rotation, it's negative. Another way to remember this is that the first move we made when we started the spiral's journey was down, and down is strongly associated with being a negative number. All right, this one here, it's negative 90 degrees, or negative pi over 2. We started there, we rotated to there, we're going clockwise. Hopefully that one's clear. Coterminal. So to figure out if something is coterminal, you got to subtract the two angles. That'll give you the angle in between them, and then divide it by a full revolution. In degrees, that's 360. In radians, that's 2 pi. So let's see, 270 minus 470 equals negative 200 divided by 360 equals negative 0.5. Repeating, this is a decimal, therefore not coterminal. Let's do the same over here. I'm not even going to rewrite them because they're kind of long. I'm just going to put a minus in between and divide them by 2 pi. Let's show that one with the on-screen calculator. Try and see the whole problem here. Okay. And I can actually put it, if I use my parentheses right, I can put this whole thing in one line. So 53 pi, close parentheses, or wait a second, pi over 36, close parentheses there, minus the quantity 125 pi over 36. We'll just do that. I'll do it in 2 lines. Divide that by 2 pi, keep the 2 pi in its own set of parentheses, pretty important. And we get exactly -1. So there is exactly -1 rotations in between these 2 angles. So this equals 1, which is or it equals -1, which is an integer. So this is yes, these are coterminal. Moving on. All right, find the length of each arc, leave pi in your answer. The formula arc length S equals r theta works, but only if theta is given in radians, which it is here, so we can just do S equals radius 9 times pi over 4. We want to just leave pi in our answer, so this S is going to be 9 pi over 4 meters. Can't be simplified any further. This one over here would be 70 pi over 4. Hopefully that's clear why, which equals 35 pi over 2 yards. Moving on. Now we've got some that give it in degrees. We got to convert that to radians. If you got your unit circle, this is one that's on there. We know it's just 3 pi over 2. So 3 pi over 2 is that angle. Now we can multiply it by the radius 13. Now we have 39 pi over 2 kilometers. And if you want a decimal approximation, that can be useful just to make sure that we get it right. Convert this to a decimal, see if that looks right, knowing that this is 13. You know, was that, it's about, should be about 4.5 times 13. So it should be about 50. 39 pi divided by 2 is 61. Okay, yeah. Close enough. Let's move on. Find the value of the trig function indicated. Notice for these, you never actually have to find theta to answer these kinds of questions. You just have to give me the ratio indicated by this trig function. Cosine is adjacent over hypotenuse. Let's see. According to this, the adjacent would be 12. The hypotenuse is 13. We got 12 over 13. That's all I need. We never had to find theta. We just had to do the correct ratio. This one is 4 over 5. If I didn't put one in, but if you need, like if we needed the adjacent for this one, we'd have to do the Pythagorean theorem and realize that this is length 3 over here. Moving on. Find the measure of each angle indicated round to the nearest tenth. So this was a common problem. I put this one in the mini quiz. You'll probably see it again on the test. Finding an angle given 2 side lengths. Well, from that angle, still label the side lengths as either adjacent or opposite or hypotenuse. Here we have adjacent and hypotenuse. I know that if I take cosine of that angle, it should give me the ratio adjacent over hypotenuse, or 8.3 over 15. If I take the inverse cosine of both sides, that's how I will isolate my theta. Someone is knocking on my door. Well, I'm recording a hotel video right now. In tomorrow maybe?
It's good to be in class.
No.
Okay.
Sorry.
It's okay, thank you.
Yeah, I really want to finish this up, but yeah, maybe next time. All right, inverse cosine of both sides. We can plug this into our calculator to get to the inverse cosine function. We have to do second cosine of 8.3 divided by 15. And we get, since my calculator was in degree mode, it gave me an answer in degrees. I think that's fine. 56.4 degrees. 56.4 degrees. All right. Find the measure of each side indicated. Let's just do one of these. Let's see, we've got, this is sine. This one uses tangent. Maybe that's a little bit more interesting. So this angle here is our important angle. We label adjacent and opposite based off of that angle. This 3 here is right next to it, so it's our adjacent. This x over here is across from it, but not the hypotenuse, so we name it the opposite. I'll just label hypotenuse, but all we need to know is that we have adjacent, we want to know opposite. That means we're using tangent. So the tangent of 63 degrees equals x over 3, multiply both sides by 3. 3 times the tangent of 63 degrees equals x. 3 tangent 63. Make sure your calculator's in degree mode when you do this, or because 63 is given in degrees. And we get length x equals 5.9 units. That is correctly rounded to the nearest tenth. Moving on. All right. Find the exact value of each trig function, sine of pi over 2. So here's what we do. This terminal side was rotated over here. We can rotate it just a little bit further so we can still construct a triangle. Still coming down to the origin with one side, down to the x-axis with the other, but then we label this side length here as 0. The opposite here is clearly 1. The hypotenuse is still 1. We can label things as opposite, hypotenuse, and adjacent. And now when I want to find the sine, that is opposite over hypotenuse. Opposite is 1, hypotenuse is 1, so 1 over 1 equals 1. All right. Here we've got another one. This one's a little easier because it does end up in one of the quadrants, so we can just put a point on the terminal side, drop a line down to our x-axis. We want to know what kind of triangle this is. Well, if I've got 135, then 45 degrees is remaining to get to 180. So this is a 45, 45, 90 triangle with side lengths 1, 1, and the square root of 2. Here we take a pause to think, are either of these straight legs, ones that go left and right or up or down, are they negative? Well, this one comes straight up, so that's definitely positive. But this one, from the origin, it came over a negative direction. So our adjacent is actually a negative 1 here. So that's the adjacent, this is the opposite, this is our hypotenuse. Cosine is adjacent over hypotenuse. Adjacent is negative 1, hypotenuse is the square root of 2. Simplify this by multiplying it by the square root of 2 over the square root of 2. We get negative root 2 over 2. put a box around that. This is what I want to see on the test. This is what you have to explain. There is a formula that also says that cosine is always the x value of the point on the unit circle where this line crosses. And if you remember unit circle really well, you realize that, yep, that is indeed the x value of that point. All right. Let's see if any of these would be particularly good. This is a 30, 60, 90, we can see. The 30 up here and the 60 here. It's only ever going to be a 30, a 45, or a 60. So you can like figure it out pretty much by guessing and then just kind of confirm by looking at the angle measurement that makes sense. That gives us side lengths 1, 2, and the square root of 3. But notice we went left, so that 1 is negative, and we went down, so the square root of 3 is negative. But hypotenuse is just always positive. It's always measured from the middle out, so that's always a positive number. Opposite over hypotenuse would equal square root of 3 negative over 2. Tangent of pi. In order to do this, we should sketch the angle pi. Here's my initial side. But I'm not going to go all the way to the axis. I'm going to stop a little bit short so I can still make a triangle. I'm just going to say that this length here is 0. The hypotenuse is 1. The bottom or adjacent side is -1. Tangent equals opposite over adjacent. So this is going to be equal to 0 over -1, which just equals 0. If you want to check that, set your calculator to radian mode, do the tangent of pi, and we do indeed get 0. All right. Using radians, find the amplitude, period, and phase shift of each function. Amplitude is easy. Amplitude is just the absolute value of the A. Amplitude here is 2, here it's 2, here it's 4, here it's 4. Period equals 2 pi over b. The b value here is 4, so it's 2 pi over 4, which equals pi over 2. Phase shift. Well, actually, let's do the period for this one. It might not be obvious, but theta over 6 can be rewritten as 1/6 theta, and the b value is 1/6. So now to find the period, we do 2 pi over 1/6. Copy that, flop that, you get 12 pi for the period. 1/6 fits into 2 12 times. All right, phase shift. This has got a formula, h over b. Our h value here is the 5 pi over 6. Notice I don't need the negative. It's always the opposite of this number, so I don't bring the negative with. So 5 pi over 6. Our b value is 4. Copy that, flop that, and we get a phase shift of 5 pi over 24. Since it's positive, we know that's to the right. Make that 24 look better. All right, graph each function using radians. For these, what I really want you doing is actually doing it in your calculator. It's too many steps to do it by all the transformations. So the question on the test about transformations will ask something simple like, what is the phase shift? What is the vertical shift? Yada, yada, yada. For graphing like this, I'm going to do it in the calculator, but that still requires a lot of steps. One is to recognize that this is in radian mode. One, because the h value is clearly in radians with having that pi in it, but also it just directly tells you to use radians. So switch our calculator to radian mode right there. We can input it now into a y equals. This first one is 4 sine. For the theta, just use x over 3 plus 2 pi over 3, close parentheses, minus 1. But now, in order to see it, we're going to have the right window. So we got to match this window here. I can tell my x values go from 0 all the way up to 9 pi. So 9 pi, just enter that directly, and it has a tick mark every pi units. And my y values are going from -6 up to 6. And there, they've got a tick mark every 1 unit. So my y scale is 1. Maybe to help, you want to turn your grid lines on. Maybe not. This grid off. It's already on this one, so let's take a look. Yeah, and we'll be able to do a pretty good job of graphing this now, or at least selecting the correct graph if this is a multiple choice. So just take that, copy it there. All right. Explain why the following formulas work. So formula for arc length, S equals R theta. Why does this work? Well, because normally this formula here works because our circumference formula, circumference is equal to pi times the diameter. All right, and R, or well, yeah, theta here is going to give us the fraction of half a revolution when given in radians. So because theta is in radians and radians directly relates to the length of the arc, all we have to do is scale by the radius. So and the reason it's radius in this formula and diameter over here is because there are 2 pi radians in a circle, so that would give you double, and then by only taking the radius, we cut it back in half. All right, so this formula works because the radius formula works. Similar sector area formula works because it's based on the area of a circle, pi r squared, and then we just want the fraction of the circle. And to get what fraction of the circle we have, we just do theta divided by 2 pi. The pi's cancel out, and we get r squared theta over 2 for our sector area. So the reason it works is because it's based off of our formula for the area of a circle. Formula for converting radians into degrees. So radians equals degrees times pi over 180. This works because this here is a form of 1. The formula for trig functions using the radius and the coordinates of the unit circle. So for that, you know, I taught you that cosine of theta is equal to x. Well, the reason this works is because if we look at a coordinate x comma y on our unit circle, x is going to be equal to the adjacent, and the hypotenuse of the unit circle is always 1. So h equals 1 always. And so cosine being adjacent over hypotenuse is always going to be equal to the x coordinate of that point divided by 1, or just x. So an explanation like that would be good. All right, moving on. There's our answer key. available on my website. Now, on to the modeling trig. We'll just try to do a couple of these. John is floating in a tube in a wave tank. At t equals 1 second, John reaches a maximum height of 14 meters above the bottom of the pool. At t equals 9 seconds, John reaches a minimum height of 2 meters above the pool. Sketch a graph below to express John's height from the bottom of the pool with respect to time. So this bottom here can just be seconds. We'll just go 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 20, 25. And let's see, has to be able to go from 14 feet height. So we got 1, 2, 3, 4, 5, 6, 7, 8, 7, 9, 8, 9. So we'll just count by twos so we can fit in that 14. So 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So at 1 second, he's at 14. Let's plot that. At 9 seconds, he's at 2. And that's the minimum and the maximum. So if it took 8 seconds to get to the minimum, or from the maximum to the minimum, it should take 8 more seconds to get back up to the maximum. So 1, 2, 3, 4, 5, 6, 7, 8. 8 more seconds to get back to the minimum. 1, 2, 3, 4, 5, 6, 7, 8. And then we're off the graph. It should take 4 seconds to get to the midpoint. 1, 2, 3, 4. And the midpoint between 2 and 14 is 8. See, that's right in the middle there. So 1, 2, 3, 4. 1, 2, 3, 4. All right, now we don't want to just make this zigzag. We want to give it a nice wave-like look. So John's motion actually looks a lot like the waves of the wave pool. Crazy how that works. And there we go. All right, it's a pretty good sketch. Maybe we need some labels, like this is time in seconds, and this is height in meters. Okay, what is the equation of this line? So we got to find out a lot of stuff. First, we got to find out amplitude. We figured that out, though. The maximum is 14, the minimum is 2. The distance between that is 12, but we divide that in half because it's only half of the distance from maximum to minimum. So our amplitude is 6. Or we could just count the boxes. 1, 2, 3. Each box is worth 2, so there's 6. K, our vertical shift. Well, we already put a point at our midpoint. It's 8 up, so K's got to be 8. B is equal to the, well, I'll say it this way. Period equals 2 pi over B. So 2 pi over B. I can tell that the period of this is every, let's see, it takes 8, and then another 8, 16 seconds. Yep, so every 16. So 16 equals 2 pi over B. Rearrange this. We got B equals 2 pi over 16, which equals just pi over 8. And H, well, we got to decide if we're using cosine or sine to figure out the H. We'll just use cosine because cosine starts at a maximum. H is going to be 1 unit to the right. But I'm going to, so that I don't have to do that H over B, I'm going to write this a little bit different. So watch how I do this. Y equals 6 cosine And here's how I'm going to change it a little bit. I'm going to put my B value as pi over 8.
Would Ria Sakara please come to the main office, and Quinn Camberos, please come to the main office. Thank you.
All right, then I'm going to add an extra parentheses here and then just do x minus 1 directly there. If I want to distribute that pi over 8, I can, but I can just leave it like this. Plus 8. There we go. What is John's height from the bottom of the pool at 21 seconds? We're going to plug in a 21 right here and solve. My calculator's got to be in radian modes because I did this in radian. So mode, it's already in radians. Let's just plug this all in. 6 cosine pi over 8. 21 minus 1 plus 8. And we get that his height is 8, which actually makes a lot of sense because if we look here at 21, yep, he's right at 8. So 8, not feet, but meters. All right, we got a pendulum one. I don't know. Riding up a bike. They're up a hill on a bike. I guess we'll do this. Number 6. Call it our last one. So these 3 girls are skipping rope. As the rope rotates, it is observed that the maximum height is 2.75 meters after 1 second. The first minimum height of 0.25 occurs 2 seconds after the maximum height. The first, okay, a second. So let's just put time down here. I'm going to count by 4s. 1, 2, 3, and then 1. All right. And for height, I need to go all the way up to 2.75. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I'd really like to be able to do fourths here, but I still have to do half meters. So 0, 1, 2, 3, 4, 5. So 2.75 after 1 second. That's 0.5, so it's a half unit there. And then the first minimum height occurs 2 seconds after the maximum height. So 2 seconds later, like so 3 seconds. And it's 0.25, so just a half unit there. All right, so that took 2 seconds. So 1 second should be right in between. What is exactly in between 2.75 and 0.25? We can figure that out by averaging them. So 2.75 plus 0.25 divided by 2 divided by 2 equals 1.5. So right at 2 seconds, right in between, we should be 1.5, which, hey, makes it's right in line with those, so that's good. And then after 4 seconds, it should have returned to that. After 5 seconds, it should be back up at its maximum. After 6 seconds, it's back at its midpoint. And after 7, we're at a minimum again. And if we go back a second, we should be back at that midpoint. All right, it's a pretty decent graph. Few wonky sections, but that's all right. All right. Now I got to write the equation. Got to do all that stuff again. Amplitude, not obvious this time, so we'll calculate for it. It's going to be max minus the min divided by 2. So 2.75 minus 0.25 divided by 2, that's 2.5 divided by 2 is 1.25. This is our k, because k is also where the midline is. Our b value, so the period here, it's repeating every 1, 2, 3, 4 seconds. So 4 equals 2 pi over b. Switch that around, and we got b equals 2 pi over 4. And then b equals pi over 2. To get phase shift, I'm going to do cosine again, and then just move it 1 unit to the right, giving us a final equation y equals 1.25 cosine of pi over 2 in parentheses x minus 1 to do the shift, close parentheses, plus 1.5. And then is there another question? Nope. All right. So hopefully this has been helpful, and I will see you for the test.